If you work in quality control at a candy factory, you know strict safety regulations come with the job. It's why you partner with Grainger. Grainger helps you find the high-quality and compliant products your business needs to inspect, detect, and help correct issues. And the sweetest part is, everyone gets a product that's as safe to eat as it is delicious. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
This is SpaceTime Series 28, Episode 35, for broadcast on the 21st of March 2025. Coming up on SpaceTime, discovery of another neighbouring planetary system, a stable trio of small worlds discovered in the dark outer reaches of our solar system, and could science fiction's idea of white holes be a real thing? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a nearby planetary system orbiting Barnard star, the second nearest star system to the Sun. Located 5.96 light-years away in the constellation Ophiuchus, Barnard star is the nearest star system to the Sun after the Alpha Centauri triple star system. We know Alpha Centauri also hosts a planetary system. A report in the astrophysical journal Letters claims the newly discovered system around Barnard star consists of 4 planets, each around 20 to 30% the mass of the Earth, and all circling very close to their host star, taking just a few Earth days to complete each orbit. It's a fascinating discovery because Barnard star has long been called the Great White Whale for planet hunters. That's because several times over the past century, different groups of astronomers have announced evidence suggesting that planets were orbiting around the star, only to subsequently be disproven. But these new findings are giving a far greater degree of confidence than any previous results. Barnard star B was first detected last year using the radial velocity or wobble method, with the other 3 then confirmed earlier this year. And the 4th planet is the least massive ever detected using the wobble method. That involves detecting slight changes in a star's position caused by the gravitational pull of an orbiting planet, which causes the spectral light emitted by the star to shift ever so slightly in wavelength, red shifting 1 minute and then blue shifting the next as the planet makes its orbit. The host star is a small spectral type M red dwarf with about 16% the Sun's mass and 19% its diameter. For a century now, astronomers have been studying Barnard star in the hope of finding planets orbiting it. First discovered back in 1916, it's the nearest single-star system to the Sun. Red dwarfs are the most common types of star in the galaxy, making up some 75% of all Milky Way stars. And because of that, scientists are interested in understanding the environments of planets they host. This effort was led by Jacob Bean from the University of Chicago. His team developed an instrument called Maroon X, which is designed to specifically search for distant planets around red dwarf stars. Maroon X was mounted on the Gemini North Telescope. Maroon X hunts for exoplanets using the radial velocity method. After vigorously calibrating and analysing data taken during 112 nights of observations over a period of 3 years, the authors found solid evidence for 3 exoplanets around Barnard star, 2 of which had already been previously classified as potential candidates. The team also combined data from Maroon X with observations from a 2024 study done by the Espresso instrument on the European Southern Observatory's Very Large Telescope, the VLT, in Chile, to confirm the existence of a 4th planet, thereby also elevating it from planetary candidate status to a bona fide exoplanet. The study's lead author, Ritvik Basant from the University of Chicago, says the newly discovered planets are all most likely rocky worlds rather than gas giants like Jupiter. However, that will be difficult to pin down with any certainty because of the angle at which the authors are observing the system at. From Earth's point of view, the planets don't cross in front of their host star. If they did, you could use the transit method, which is the usual way for determining a planet's composition. They were, however, with a fair degree of certainty, able to rule out the existence of other exoplanets with masses comparable to the Earth within Barnard star's habitable zone. That's the region of space around a star where temperatures are warm enough to allow liquid water, essential for life as we know it, to exist on a planet's surface. Most rocky planets found so far are much larger than the Earth, and they appear to be fairly similar throughout the Milky Way galaxy. But there are reasons to think that smaller exoplanets probably have more widely varied compositions. As scientists find out more about them, they can begin to tease out more information about how these planets form and what makes them likely to have habitable conditions. This is SpaceTime. Still to come, a stable trio of small worlds discovered orbiting in the outer reaches of our solar system, and could science fiction's fabled white holes, the opposite of black holes, be a real thing? All that and more still to come on SpaceTime. Astronomers have discovered a stable trio of small frozen worlds in the dark outer reaches of the solar system's Kuiper Belt. This distant, sparsely populated region of space is inhabited by comets and icy debris circling the Sun beyond the orbit of Neptune. The new discovery, reported in the Planetary Science Journal, was made using observations by NASA's Hubble Space Telescope and the giant 10-metre Keck twin telescopes in Hawaii. If confirmed, it'll be only the second such three-body system found in this remote outer edge of the solar system. The system's being catalogued as 148780 Algiera. The study's lead author, Maya Nielsen from Brigham Young University, says over 3,000 Kuiper Belt objects have been catalogued so far. But scientists estimate there could be several 100,000 more objects in the Kuiper Belt measuring 10 kilometres in diameter or more. The largest Kuiper Belt object found so far is the dwarf planet Pluto. The Algiera system is located at the outer reaches of the Kuiper Belt some 6 billion kilometres away. Now, to put that in perspective, that's 44 times further away from the Sun than what the Earth is. The new Hubble images show two Kuiper Belt objects located 7,600 kilometres apart. However, further observations of their unique co-orbital motion suggest the inner objects are actually two separate bodies that are so close together they couldn't be distinguished at such a great distance. Nielsen says that with objects this small and so far away, the separation between the two inner members of the system is just a fraction of a single pixel on Hubble's camera. So astronomers needed to use non-imaging methods to discover that it really is a triple system. So they gathered a 17-year observational baseline of data from Hubble and the Keck Observatory, watching the orbits of the Algiera system's outer body. Over time, they saw the orientation of the outer object's orbit change, indicating that the inner object must have been either extremely elongated or it was actually two separate objects. And their calculations showed that a triple system was the best fit for the Hubble data. Now, other possibilities included the inner body being a contact binary. That's where two separate bodies become so close they actually touch each other, or alternatively, something that's oddly flat like a pancake. Currently, there are about 40 identified binary objects in the Kuiper Belt, the largest known pair being Pluto and Charon. The only Kuiper Belt objects that have really been explored in any detail are the Pluto system and the small Kuiper Belt object Arrokoth, both of which NASA's New Horizons spacecraft visited in 2015 and 2019 respectively. New Horizons showed that Arrokoth was a contact binary, in which the two bodies gradually moved closer and closer together till they finally made contact and merged, resulting in a sort of peanut-shaped object. The authors estimate that Algiera is probably around 10 times larger than Arrokoth. That makes it about 200 kilometres across. Nielsen says it's now entered an eclipsing period, during which time the outer body passes in front of the inner body as seen from Earth. This will last for the next 10 years, giving scientists an opportunity to learn more about the system. This report from NASA TV.
Kuiper Belt objects, also known as KBOs, are icy remnants from the early solar system located beyond Neptune. There are over 3,000 cataloged KBOs so far, but scientists estimate there could be hundreds of thousands more, each over 10 miles in diameter. The largest KBO is the dwarf planet Pluto. While these distant objects typically don't form their own systems, researchers have likely identified a stable trio of icy space rocks in the Kuiper Belt. This discovery of the Algiera system, made using data from the Keck Observatory in Hawaii and NASA's Hubble Space Telescope, could mark only the second three-body system found in the region. If confirmed, the Algiera system hints at the possibility of more such triple systems awaiting discovery. These formations challenge the idea that collisions in the crowded Kuiper Belt produce such groups. Instead, they support the theory that triplets like these form directly through the gravitational collapse of material in the solar system's early disk, around 4.5 billion years ago. While stars are known to form as pairs or triples through gravitational collapse, researchers are still investigating whether this process applies to Kuiper Belt objects. The Algiera system lies 3.7 billion miles away, or 44 times the distance between Earth and the Sun. Only a fraction of a pixel on Hubble's camera separates the two innermost members. Studying such distant, faint objects orbiting so close together requires patience and persistence. Using Hubble and Keck, scientists observed the system with data spanning over 17 years. This long-term study shows us Hubble's incredible value to astronomy. After more than 30 years in space, Hubble can revisit objects days, weeks, months, or even decades later, helping us uncover the mysteries of the universe, one observation at a time.
This is SpaceTime. Still to come, a new hypothesis suggests that black holes could transition into so-called white holes, ejecting matter and potentially even space-time into the universe. And later in the science report, scientists discover the earliest reported fossil of a human face ever found in Western Europe. All that and more still to come on SpaceTime. Although Albert Einstein first predicted black holes in his theory of general relativity way back in 1915, that's more than a century ago, it wasn't until 1971 that Cygnus X1 was announced to the world as the first confirmed stellar mass black hole. Today, black holes are best described as places where gravity is so strong nothing, not even light, can escape. Put simply, they're singularities of infinite density in zero volume. For years, science fiction writers have speculated what happens when one falls into a black hole. Now, the physics of Einstein's general relativity tells us that you'll simply fall forever towards the singularity as time slows down and eventually stops. But in the process, you'll get spaghettified, being stretched and crushed along the way as you're destroyed by the immense gravitational forces. The problem is, science's understanding of physics and space-time breaks down at the singularity. And so this is where more fanciful ideas, like wormholes to other places in space and time, come up, sometimes from serious scientists. Now, a new hypothesis suggests that black holes may transition into so-called white holes, ejecting matter and potentially even space-time back into the universe. The study by researchers at the University of Sheffield proposes a revolutionary link between time and dark energy, suggesting that the mysterious force driving the universe's expansion may be used to measure time. The authors believe their research could pave the way for groundbreaking new fundamental theories and breakthroughs in science's understanding of the universe. They say science's understanding of black holes, space-time and the mysterious accelerating expansion of the universe through dark energy, which dominates the cosmos today, could be revolutionized, helping unravel the mysteries of the cosmos. Using the laws of quantum mechanics, the fundamental theory describing the nature of the universe at the atomic level, the new study, reported in the journal Physical Review Letters, proposes a radically different theoretical standpoint where, rather than the singularity signifying the end, it could represent a new beginning. While black holes are often described as sucking everything, including time, into a point of nothingness, this new paper suggests that white holes are theorized to act in the reverse, ejecting matter, energy, and space-time back into the universe. Now, the study is using a very simplified theoretical model of black holes known as a planar black hole. Unlike typical black holes, which have a spherical shape, planar black holes' boundary is flat, just 2 dimensions. Now, the authors suggest that the same mechanism could also apply to a typical black hole in the real world. The authors, Stefan Gilin and Lucia Mendez-Pidal, say there's long been a question as to whether quantum mechanics could change science's understanding of black holes and provide new insights into their true nature. They say, according to quantum mechanics, time doesn't end because systems perpetually change and evolve. And by using the laws of quantum mechanics, the black hole's singularity is replaced by a region of large quantum fluctuations, tiny temporary changes in the energy of space, where space and time don't end, but instead transition into a new phase called a white hole, a theoretical region of space-time thought to function in the opposite way to a black hole. As such, a white hole could be where space-time begins. The authors say while time is in general thought to be relative to the observer, their research suggests that time could be instead derived from the mysterious dark energy which permeates the universe. So they propose that time is measured by dark energy, and this idea is pivotal in allowing their hypothesis to grasp the phenomena occurring within a black hole. So the new study is using dark energy almost as a point of reference, with energy and time as complementary ideas that can be measured against one another. Tantalizingly, the theory that what one perceives as a singularity is actually a beginning suggests the existence of something even more enigmatic on the other side of a white hole. And that, hypothetically, means one could have an observer pass through a black hole, through what one thinks of as the singularity, and then emerge on the other side, through a white hole. Right now, it's still science fiction, but it's fascinating to ponder. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that slushy sickness could be a real problem for kids. A report in the journal The Archives of Disease in Childhood looked at 21 cases of acutely ill kids linked to drinking glycerol-containing slushies. So researchers now believe it might be time to revise public health advice on the icy beverages. They found excessive consumption of glycerol by children can cause headaches, nausea and vomiting, especially in young kids, potentially leading to shock, low blood sugar and fainting when consumed in high levels. Problem is, because drinks containing glycerol can be advertised as being sugar-free, parents are often misled into believing they're actually better for kids to consume. Scientists have found the earliest reported fossils of a human face in Western Europe. The discovery, reported in the journal Nature, will help researchers better understand the lives of the first Europeans. The fossils, which were unearthed at a site in Spain, had preserved parts of a human face that date back between 1.1 and 1.4 million years. It was buried 2 meters deeper than a similar fossil previously uncovered at the same site. They say it's unclear what species of human the face belongs to, but it bears some striking resemblances to Homo erectus. Importantly, stone tools with animal bones with cut marks were discovered near the fossil, which gives scientists an indication of the sort of life this person lived. There are growing warnings today that butterfly populations across the United States are now in alarming decline. A report in the journal Science found that the total abundance of butterfly populations has fallen by 22% in the last 20 years. The authors used data from extensive butterfly monitoring efforts across the contiguous United States, integrating 12.6 million individual butterfly observations from more than 76,000 surveys, which were conducted between the year 2000 and 2020. They found the widespread decline was largely driven by sharp population losses in many individual species, with 33% of species showing significant declines and only 3% experiencing any sort of gains. Over 100 species declined by more than 50%, including 22 that suffered losses exceeding 90%. They say the findings emphasize the urgent need for conservation action. There's a new warning today about the pseudoscience of so-called sound healing. That's a claim that you can cure all sorts of diseases using nothing more than the right kinds of sounds. Tim Mendham from Australian Skeptics says, on the contrary, it can actually be quite dangerous, especially if its promoters are preventing patients from getting proper medical treatment.
In modern sound healing, in modern sort of pseudo-medicine, it's sort of sound can help you relax. It's for meditation and that sort of thing. Whether that means running a little stick around a bowl and making that sort of humming sound, or whether it's hitting a gong or knocking some tuning forks together, which doesn't sound particularly relaxing to me, but never mind. All these sounds can be used to make you relax, but it's also being pushed now into sort of further applications, they say. And I'm looking at a site by the Academy of Sound Healing, which is in the UK, which says that healing sounds and music and sound healing instruments can improve your multidimensional well-being by creating a beautiful experience where all layers of our luminous energy field, body, mind, soul, spirit, are awakened gently and lovingly. It's all nice and sweet, but not just help you relax and meditate and be a nice sort of gentle sound in the background, cutting out all the unpleasant sounds, but they're actually saying it can be used to cure things, all sorts of diseases, serious medical conditions. And in fact, some of the problems is that it can actually sort of make you worse. If the sound interferes with your relaxation, it can actually put you on edge. And these things are unregulated. So basically the academies or practitioners can make any sort of claim, and there's no need to justify it apart from anecdotal experience, which is not worth very much. So sound healing, initially, nice, relaxing, and you've got to be really careful of someone that takes something nice and applies it to something manipulative.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.